Hello everyone, good afternoon. I'm Anush Arvind and I have with me Arumugaraja. We both are site reliability engineers at Freshworks, and the product that we work for is Fresh Service. It is an IT service management product having all the typical ITIL features including IT service management, asset management, operations management, service catalog, knowledge base, and so on. And we have a very complex architecture. There are a lot of moving parts, and we have a bunch of stateful servers in that, some for transactional data, some for configurational data. And since day one till now, we've been continuously innovating and scaling it from a very small application to an almost enterprise grade application today. And one of the innovations that happened along the way was in-house Redis. So the stateful server and the migration that I'm going to talk about today involves a Redis migration. And we are using Redis for configurational data store. The transactional data goes into a MySQL database backed by Amazon RDS. And the configurational data was running in a Redis server, basically for fast reads and writes, and it was present in Redis Labs server. And some 6 months before, we developed an in-house Redis solution. Our database admin team did that, and there was a company-wide decision to that everyone migrates their Redis servers to this. And that was the task that came to our team also. And when we were supposed to do that, I was faced with this question. So I'll ask the same question to all of you. Say you have a production application running and you need to do a migration. Who all thinks downtime is the way to go? Raise your hands. Okay, you guys are very brave. Who all thinks no downtime is the way to go? Okay, yeah, that includes myself also. Basically, I did not want to put a schedule maintenance on our product status page, take it down for some time, and then do this migration. I was having a conversation with one of my friends who is actually in the energy industry, and he is also a user of SaaS products. And he was telling me the problems that they face when a SaaS application that they are running their businesses on goes down. And typically say we need to do a migration, what are we going to do? We would find the least traffic time, which is a Sunday, and we choose to do the migration. Now, in order to handle that, to make sure their pipelines work fine and all that, they need to work on a Saturday night to make up for the downtime that we are announcing. And with the message that I really felt was that innovation should not come at the cost of customer experience. So that is why we decided to go ahead with a no downtime migration solution. So the next part, a brief introduction into stateful servers. I guess most of you already know them, but stateful servers are servers that maintain data, your database servers, file servers, messaging servers, etc. When it comes to compute servers, there's no real challenge in migrating them from one place to another. Just boot another bunch of compute servers and point your traffic there. But when it comes to stateful servers, it actually contains data that your application needs to persist and respond with. That, how are you going to migrate from one place to another place without downtime? So that's where real-time replication comes into place. For MySQL, for example, there is a binlog-based replication available. And similarly for Redis also, there is a command called slaveoff, which can be used to make one server the live replica of another. But the problem here is slaveoff is only supported within single managed service of Redis. When you want to go from one managed service to another, they don't connect very well with each other and allow commands like slaveoff. It is more used for like a master slave architecture, or you're running in a cluster mode and you need the replication. For that, it is supported, but not for this kind of a use case. And again, consider that the slaveoff also would only support entire server-to-server replication. What if you need to split your database into two? Move this data here and this data to another server. So namespace-based, database-based, or even key pattern-based replication, none of that is supported. So we wanted a solution that could really do all this, and we can customize to the level that we want and do a migration and establish it as a proper real-time replication so that we can do the migration without a downtime. And the problems that if you need to do a traditional migration where you announce a schedule maintenance and you inform a downtime and do it, you are going to disrupt your own business, you are going to disrupt your customer's business also. And say you announce a downtime for 10 minutes and do the migration, you run into some problems, you face some surprises, it could even extend. And again, you scale for 10 minutes of downtime. If that takes 20 minutes, what are you going to do then? If you need to again do a rollback, say something went wrong, you need to extend the downtime to do the rollback as well. And again, testing challenges. Your app is down, so what are you going to test? Because of all that, we chose not to do the traditional migration. And this is the live replication solution that we built for a Redis server to another Redis server. And note that this is a completely customized solution. You can migrate any data set that you want. And also this can happen between any two Redis servers, in-house or managed service, anything. And Arumugaraja will explain how that is done.
Hello guys. Thank you Anush for setting a clear context on why we went with the no downtime approach and why we have to reinvent the wheel while multiple managed providers are already providing the replication. So as Anush mentioned, they are supporting the replication inside their network only. Like from one managed provider, you can replicate to the same managed provider. When you want to move to the separate managed provider or like us in-house Redis, you won't have an option from them. So with that only, we went to this approach. So before going into the approach, I'll take 2 minutes on explaining this main command, which is the core of this replication. So you can see the command name is monitor, which is a Redis command. So what it will do is, it will we will run in the source instance. Source instance is the instance from which we are going to migrate to in-house Redis. Here is the destination is in-house Redis. Okay. So this monitor will run in the source instance and capture all the commands that are getting executed in the source and stream it to somewhere. So that somewhere we can decide. So in our case, we chose it as a queue. Okay. So any command that we are running in this will be monitored by this monitor and streamed to our queue system. So one more point, main point here is this monitor command is an intensive command. So it will take extra CPU, okay? So if you are running a production workload at 90% of CPU, then if you are running this during your migration, you will face a downtime, that too without a maintenance window. So it is more worse than the maintenance window downtime. So you have to be cautious on taking a call like this. So you have to be sure that you have enough space to run this command and you have additional space to handle the abnormal load during the maintenance window or during the migration. It is always better that you have minimum of 20 to 30% of buffer for your production workload. So with this, so from source, we are copying the, we are streaming the commands that are executed in the source through monitor. Here you can see the cross, right? So it is not yet replicating to the destination. It is just streaming right now. So here in the next step, this is the step 1 and the step 2 is from source, you can take a snapshot that is supported by all the managed providers, right? So from the source, you will take the snapshot for a point in time. Say here the time is X we mentioned. So for the time X, we will take the snapshot copy and boot the instance in the destination side. So now all the data that is present in the source at time X is present in the destination. Okay. Now with this, we will move on to the next one, which is the major part. So here we will run a consumer. In the step 1, we have streamed the data to the queue, right? From the queue, now we will consume the data. What that consumer will do is that will consume the data and replay the command that are executed in the source. Because monitor has given you the exact data that are ran in the source. For example, if I am setting a key, set A as some GDG. So here the queue will have the data A GDG. When this consumer is reading, it will read the data A value as GDG. It will simply replay the same command and destination will have the same data. Now you might be thinking, you have started monitor already and after that only you taken a snapshot. And now you are consuming all the commands means there can be a duplicate, right? Or there can be a overwrite. So to handle that, whenever we are starting the consumer or whenever we are taking the snapshot, we note down the time. That time we will have it in our replication consumer code and that will be referred always. So anytime when we are reading the command from the queue, we will check whether that command got executed after that point in time or before that point in time. If before that point in time, we will simply ignore because that is already copied from the snapshot. So no action needed for that part. Only the commands that are executed after that point in time, we will simply replay. Okay, so the data that copied from snapshot is already available. The data or the command got executed and data got updated after the snapshot will be replayed. So now I am talking a lot, right? Anush, my lead, who don't like talking a lot, he will show you the demo.
Hey, thanks for setting all the context, Aru. I'll need two hands to do the demo. Maybe you can hold the mic for me. Yeah, so we've been showing a source Redis and a destination Redis, and we've shown 3 steps here, right? Monitor, snapshot, copy, and then processing of the commands to do the real-time replication in the destination. I'll actually do a live demo of that and show you. In my system here, I have 2 Redis servers running, one in port 6379 and one in port 6380. And here I have 2 clients connected to 6379. So these 2 are the source. And here I have 2 clients connected to 6380. These 2 are the destination. So let's, initially my Redis server is actually empty. There are no key value pairs present. Let's go ahead and set some initial data in this. So I'll set A as A and B as B. Now we have 2 keys here. And I'll run monitor command here just to show you how it works. And let's do a set C and C. So this value has been set, right? You go here and see, you see the set C command is output this way. So this is exactly what the monitor does for you. Let's go ahead and run a monitor in the destination also. And the first step that you saw was running the monitor command and pushing everything into a queue. I have Ruby scripts for everything. These are very simplified versions of what we ran in production. First, I'll run the monitor command. Nothing is processed from the queue yet. And then there was a point-in-time snapshot restore. I have a script to do the same. I'll run that in another console. So now you actually have your destination as a copy of your source. So in the destination Redis, I'll go check what are all the keys now. We have this A, B, C. These are the 3 keys that we set in the source originally. And the start time is manually set from the script context in order to ensure that the time context is set. So all the commands executed after this will be replicated real time. Now I'll run the processor script also. This is going to listen to all the events in the queue and replay them in the destination. Now we will go here and set a 4th key, set D as D. Now what happens here is that this set D command is going to execute in the source, but we are running a monitor command here. This is going to push it to the queue, which we saw in the slide, and then this is going to poll that from the queue and execute it in the destination. So now we come to the monitor of the destination. We see that the same command has been replicated here. Now I'll go run a get D. We get the value of D. So this is how the actual real-time replication has been handled. And let's go one step further. I don't want to keep doing this myself. All of you can actually participate in this. I have a small application running which is connected to my source Redis. So I just go type my name here and ask it to submit it to Redis. What this does is that in my source Redis, you can see, right, this submits the message here. So similarly, I'll open this up for all of you, and all of you can maybe try submitting your name here. All of that is going to be submitted to my queue, come into my console, and then get populated into the destination Redis. If we open the destination Redis, we can see here that command has been replicated. So why don't all of you take part in this? Just scan this code to get access to the server, and try sending your name to the server so that we can watch all of that also get replicated real time. I'll give a couple of seconds for all of you to do this. Or you can also take part.
Thank you, bro.
Thanks everyone for the response. Looks like we've already hit the server limit for my local server. I hope everyone had a chance to scan by now. Okay, I guess that's about enough. Let's go to the source and see. Yeah, we have so many names submitted here. Now let's go to the destination. Hope everyone can find your name here. So this is how, in a local server, we've actually done a Redis replication with all of you people here. Now just imagine scaling this for a production scale, and you optimize your scripts that are going to do this, and build a highly available queue and scale this up to production. You can do this for an enterprise level production application also. Yeah, you can take it from here, Aru.
Yeah, thank you. Now my lead is very happy that we have done the replication, but our job is not done fully yet because we just did a replication, right? We have not did a rollout or anything. So before doing the rollout, I would just spend few more minutes on explaining our architecture in a simplified format. So whenever we are receiving any request from the internet, we will have a HA proxy which will do the layer level routing during the non-deployment time. During deployment time, it will do an additional work of routing to the different color based on the traffic type at that point in time. During the 10% of switch, it will route the 10% of traffic to the new color, and 90% to the old color, which is running with the old code. And once that part is done, we will have an application server which is running on as a sidecar. There we will do additional some processing for our like routing and other stuffs that we are not the things that we are doing in the HA proxy. So once after the Envoy level, our fresh service application will be reached, and this is backed with the multiple stateful servers, like Anush mentioned, RDS for transactional data and Redis for configuration data, and it also holds couple of transactional data, and S3 for file store. So you can see that Redis is connected with the background servers as well. So let's take the deployment step. So HA proxy is now running with only one color, which is serving the 100% of traffic right now. So any request that is coming to the HA proxy through the internet will be automatically forward to this single color only. And in the next step, this you can see here, this one is right now pointing to the source Redis from which we did the replication. Now in the next step, we will boot the non-live. Right now it is the green color. So in this one, we will have a Redis, destination Redis. So here this dotted line depicts that we are having a replication in place already. So right now, the replication is 100% in place, and we are doing the switch. So right now what we have to do is, we have to switch this live to non-live. So from blue to green, we have to do a traffic switch. So usually when we do the traffic switch, or when most of you guys do the traffic switch, you always prefer to do in an incremental way, right? So then only you will be ensuring that your premium customers or all the customers not getting impacted at the same time. So that is the similar way we also follow, but that won't applicable here. Why? Because we are doing a live replication. Okay. Right now, if I want to do an incremental rollout, let's say I am doing a 10% traffic switch. So 10% traffic will be writing the data to the destination, and 10% remaining 90% doing the write in the source, right? So the data will be, there can be a mismatch in the data, because only the 90% data is copied to the destination. The 10% that we are writing will only known to the destination server, which won't be available in the source. So to avoid this one, what we did is, we did a atomic traffic switch with the timed script. So we will have a script in the HA proxy that will be doing a atomic switch at a single point itself. So when HA proxy doing the traffic switch, immediately from that millisecond, all the traffics that are going to the blue will be cut down and 100% traffic will be routed to the destination. This way we will ensure none of the data is written in the green, which is unaware to the blue at that point in time. So once this step is done, we will bring down the non-live color, because right now the deployment rollout also completed. So now the entire traffic is moved to the green color, which is backed with the destination Redis. Okay. Yeah. With that being said, I would request Anush to take it further.
Thanks, Aru. That was very insightful. Now that we have seen a live Redis replication, and we've also done an explanation on how to do a no downtime deployment, what's the point of doing all that? The problems that we discussed before, right, all of them stand out as advantages now, which includes zero disruption to your business. And because of that, your team is more happy, your customers are more happy. And this continuous revenue generation continues. It doesn't stop. And everyone else becomes happy, and you just keep your business growing. And if you are really looking to hit the enterprise grade in production, really downtime is not a very good experience for any customer. That is what we also wanted to do as a part of this. Now, next, all of you get back to work, and you are getting some migration like this in your work. And you need to do something like this. What are the best practices that you should follow? I'll give some of the pointers. The first step is you need to do proper pre-migration analysis. So completely understand how your compute layer talks to your data layer. Understand all the use cases. What are all the key, in the case of Redis, we had to understand what are all the keys that were written, what are all the structures, and when you run a monitor, what are all the patterns that get outputted, how to parse each of that, and how to run all of that into destination. And redundancy is very important. You need to ensure that at any level there are some failures, there are other backups to take care of that, and your flow is not interrupted. And ensure that your replication is real time. You obviously don't need replica lags and then do a traffic switch in production to show an inconsistent database, because it is even better to be down rather than show wrong data to your customers, right? And ensure that you have proper failover and rollback procedures in place. You run into production and you run into some surprise there, you should be able to immediately fall back to the previous version and keep your application up and running in a consistent state. And how do you do all of that? How do you decide? You need the right observability for that. So for all these scripts also, how you have observability for your production application, ensure that you have that for your Redis replication and deployment also. And always be prepared for the worst case scenarios also. So I would like to ask a question next. A good developer, once finishing writing the required code, what do they do next? Exactly. So after you finish your code, write the required tests. And similarly, I have explained about this Redis replication to all of you. Now I'd like to keep a test. Before I open the session for Q&A, I'll ask you some questions. And basically how you understood this, let's figure that out. We spoke about the processing real-time commands from the queue, right? So consider you have a particular key that gets updated very frequently. And you have a very small scale application, means you can use a FIFO queue and you can have a single processor and process all the messages in order. Now consider you're running an enterprise level application. In our case, it was 35 million keys and 5 billion operations in a day, which is around 4.5 million operations per minute. For that scale, we obviously have to run a very highly available queue and a lot of multi-threaded processors. In that, how do you handle out-of-order messages? Anyone has any idea? Yeah. Maybe the room is small, you can just shout your answer. Yeah, that's right. Yeah, now timestamp is a very good option, but say now I get a message saying, let's assume 1, 2, 3 for timestamps. Now say I get a message for timestamp 4 and I feel fine and I run it. And after that, I receive a message for timestamp 3. Because in queue, you can get it out of order. I don't know what is the next timestamp that is going to come to me, right?
So, I mean, like, you will have to then use a proper, I mean, a queue which does the ordering for you.
But a FIFO solution won't scale for 4.5 million requests per second per minute.
I mean, you can have multiple servers that can do the partitioning for you. The key that you, I mean, it can partition the keys for you. So your keys will obviously arrive in order at that particular key.
No, okay. Next, I'll make it even more complicated for you. One partition cannot scale enough for a single key. What do you do then?
So the number of keys is more, yes, the updates is more. So
Everything, yeah.
yeah, single partition for that key, it will be under a lot of load. Okay. Yeah, so I'll think. But
Yeah, but great try. Thank you. Anyone else? Okay, so this was the first problem that I ran into when this solution was being implemented. So basically for keys that are getting updated very frequently and we need to process them out of order, first thing, identify all those keys. And in the real-time replication, just for those keys alone, when you face an operation for that, get the latest state from source and dump that into destination instead of replaying the command. Simple as that. That's all. Why not do this for all the keys? It's very safe, right? The point is you'll end up loading your source more than necessary because you already have the command here. That's the solution. Okay, next one. We saw that in the best practices, I asked all of you to ensure that a rollback solution is available, right? After you do your traffic switch, you've pointed everything to destination, and say you are facing a sudden high CPU utilization or you are facing a Redis latency, you need to do a rollback. You do a rollback, but what about the traffic that already reached to your destination? How do you ensure to do a proper rollback? Anyone? Yeah, but your source already has some keys before the traffic switch. Correct. Correct. Yeah, that's correct. That's 90% correct. So basically, do a reverse replication once you start doing a traffic switch. The monitor command that we saw and we were pushing everything to a queue, right? Have a secondary queue for that and do reverse replication continuously. So both your source and destination are always in sync, no matter what is live, what is non-live. So you can always switch from anywhere to anywhere, and that makes your solution very robust. That's it. Yeah. Now I'm ready to take questions. Yeah, whatever we saw here is the master to master replication. So across managed servers, you don't have that available, the master to master replication. You can use it for master slave architecture or cluster architecture and all that. But say you want to go from an Elasticache to Redis Labs or Redis Labs to in-house. For all those solutions, they don't offer the exact replication solutions to you. So so, okay, so did you miss the introduction because I explained all of this at the beginning? So I'll explain that. We were actually originally running on Redis Labs, and we have a database admin team who in-house built the solution itself. And we did a lot of evaluation on build versus buy, and with the licensing and all that, and we felt that an in-house solution is much better. It's fully customizable by us. We own it completely. We control the deployments, versions, and so on. So that's why we had to do a migration from that to this. DMS is available for MySQL and all, not for Redis. Yes. Yeah. Thanks. Hey, I think he has one question. Maybe we'll finish that and go ahead. Hey, wait, I can't hear you. Wait. Here.
Hello. Yeah, this is good.
Yeah.
So first of all, I like the approach.
Thanks.
That's actually amazing.
Thank you.
I'm not expert in the domain, but I have a question regarding the intellectual property. This is an in-house solution, right? So do you
Yes.
guys have a patent for this, or is it open source, everyone can use, or what is it about?
Sorry, can you repeat that? I didn't.
Is it open source, or do you guys have patent, or how does it work?
We are still figuring all that out. We just finished the migration a month back, and
Okay.
we felt it was great, so we are talking about it here. That's all. We are yet to figure out the future on this.
Okay. Yeah. Thank you.
Yeah.
So, why not? So this entire problem exists because all of our Redis is tied to a particular machine, right?
That's right.
So why not have a central Redis which sort of serves both of these, and then we would not even have this sort of issue happening, right? Like for example, at PayPal we use something called JunoDB, which is sort of like a database for each of the instances. Also, it sort of syncs it to a primary DB, right?
Got it.
So what we generally do is all of the requests generally also is replicated to with live sync happening. So my question being, is there no other solution that does this? Something like
Yeah.
that also replicates to a master DB. Like since we here you had to do it manually, right? So if this is a problem that is common, I'm pretty sure there must be something. So did you find something along these lines?
We couldn't, and that's why we had to develop all this.
All right.
So this is the same what Redis Labs does in the cluster mode.
Okay.
But we are moving from Redis Labs to in-house, right?
Okay, okay.
So there it won't be applicable. When
Right.
we have to scale our Redis cluster. In the Redis Labs, this will be applicable because they are already doing the same in the cluster mode.
Right, right.
So when we are moving from Redis Labs to here, that won't be applicable. That's when we have to reinvent.
Right. So, so probably the next version of the in-house application would probably also include a master replication with the local instance as well, right? So
That is also we are doing right now. That is also available only in the in-house.
Right,
So the problem here is when moving from in-house to
correct.
somewhere.
Vendor change is always a problem.
that is the problem.
And now we have in-house, and we also have this solution ready. So going forward, we are not going to have anything like this. But this was the stage that we came to this level. So. Thank you. Yeah, thanks for all the questions. Thank you, everyone.